We'll do these bottom ones, and then you guys see all these? And then I'll flip it up to 40s. Section up here. That one after school. B you can just do. You just take dy dx and then you just do it in terms of t. So you take the second derivative in terms of. Tell me how you solved this problem.
It was a circle, and since it's on 0, 0, it's the normal line of the tangent line is the radius.
Wait, which one? Okay, so two different things.
What you're talking about?
The normal line is
the radius.
Yes. So
it will always be perpendicular to whatever tangent line because it's a circle.
How do you know that normal line? How do you know that is a normal line?
Because it's perpendicular.
How do you know that? Like what you're doing is taking, like from circles back in the day, like learn like a tangent line is perpendicular to the radius. Yes.
Yeah.
So you're using what you know to prove it. That exact statement. You know what I'm saying? The goal of this assignment was to use calculus to prove that statement. Do you know what I'm saying?
Okay.
Does that make sense? You're like, of course it is, because it is. You know what I'm saying? Which is good for like back then, but like how can we prove it now? And like here's how you can actually prove it. So you got some circle, pi circle.
Hi.
Yes. Hi. He's just a little shy. So you got a radius and you got a tangent line. And it's for any point. So if your x value is 2 cos t and your y value is 2 sin t, any point is going to be, this point right here, is going to be the point 2 cos t, 2 sin t. Does that make sense, guys? That's the point on this circle where that tangent line is. Okay, I chose a point. What's a way to figure out the slope of that radius, given that point? Is there any way just to figure out the slope of that line, that little black line I drew?
Triangle.
Huh?
Can you do that? No.
Well, I mean, you can draw a reference triangle, but I just want literally the slope of the hypotenuse then. How could you figure out the slope of the hypotenuse? Yeah.
Could you do 2 sin t over 2 cosine t?
Why is it equal to that? What did you do? It is equal to.
Over change in x.
It is the change in y over change in x. What other point are you using?
0, 0.
There you go. You also have this point. Does that make sense, you guys? If you wanted the slope of that line, you can do change in y. y2 minus y1 over x2 minus x1. Does that make sense, you guys? And the slope of the radius, using that, would be 2 sin t minus 0, or just 2 sin t, over 2 cos t minus 0, or 2 cos t, which simplifies to just sin t over cos t, if you just cancel the 2's out, or the tangent, or whatever you want to call it. Does that make sense, you guys? Any questions on what I just did? I just want the slope of this line, and again, it's for any t, so let's test one. Let's make sure it works. If I go 0, if it is a reference triangle and unit circle, if I just send this thing straight over, at time 0 you're going to be here. What's the slope of that radius then? What's the sine of 0? Say it together. Everyone practice your trig. What's the sine of 0?
0.
Y length of the reference triangle is 0. What's the cosine of 0? What's the x length of the reference triangle? What's 0 over 1?
0.
Yeah, the slope, at that point, if the radius was here, the slope would be 0. Does that make sense? What about if you send it up to pi over 2? If you're up here, what's sine of pi over 2? What's the y length of the reference triangle pi over 2?
1.
What's the cosine of pi over 2?
0.
So what's the slope of that radius? Undefined. Really steep. Infinite slope. Does that make sense, you guys? So this is a little guide, a little equation that will give you the slope of the radius at whatever time you want. Okay? So now I need the slope of my blue tangent line. How do you figure out slopes of tangent lines?
The opposite.
So that is, we can if you knew that it was perpendicular, you could say it's the opposite reciprocal. That's what I want to prove. My question was, how do you figure out the slope of a tangent line? Derivative. Yes? How do you figure out the slope of the tangent line, Estella? Finding the derivative. Derivative of what? I want dy dx. How can I figure out dy dx? Times?
Or divided by...
Oh, I like how you said it, dt. You want to switch it up. Did you see what she did, you guys? That would work. You could get dy dx by doing dy dt times dt dx. This would work because the dt's would cancel out. This would be change in y in terms of t, what I can do. This one would be change in t. So, I don't know, I don't like that one. It's all flipped up. Do you know what I'm saying? So what does this one have to be?
We can divide by dy, dx dt.
Yeah, you divide by dx dt. And then that would be the same as times, exactly like you said. Good call. So can I do dy dt? What is the change in y in terms of t going to equal? Yeah, take the derivative of this in terms of t. dy dt is going to equal 2 cos t. What's dx dt? Negative 2 sine t. So what is dy dx? What's the slope of the tangent line? Why is everyone whispering?
It's
Wayman, what is it?
2 cos t over negative 2 sine t.
Then what are you waiting for? Why are you just sitting there hiding? Are you afraid to say that? What if you were wrong? Like you are now. Are we all going to make fun of you? A little bit? Is he wrong? No, then why is he keeping it in? Why are we letting the room go dreadfully silent and dragging on? dy dt over dx dt. dy dt is 2 cos t. Dx dt is negative 2 sine t, which equals negative cos t over sine t. Now, what do we notice, Lauren, about the slope of the radius compared to the slope of the tangent line?
It's the opposite reciprocal.
They are opposite reciprocals. That is what we're going to use that to prove that they're perpendicular. You see the difference, you guys? That is the proof for what you learned back in the day. There's a proof for it. Okay? But we needed slope of the secant line, and we needed derivative in order to do it. Does that make sense? Was that fun? I said, was that fun?